Determinant. Let's learn. Vertical line A, B, C, D, vertical line, is a determinant. A, B, C, D are rows and A, C, B, D are columns. Degree of this determinant is 2 because there are 2 elements in each column and 2 elements in each row. Determinant represents a number which is AD minus BC. That is, cross multiplication of elements of determinants A, B, C, D is equal to AD minus BC. AD minus BC is the value of determinant A, B, C, D. Determinants usually are represented with capital letters as capital A, capital B, capital C, capital D, and so on. Solved examples. Example: find the values of the following determinants. 1. Determinant A is equal to 5, 3, 7, 9. Solution: determinant A is equal to 5, 3, 7, 9, which is equal to 5 into 9 in brackets minus 3 into 7 in brackets, which is equal to 45 minus 21, which is equal to 24. 2. Determinant N is equal to minus 8 minus 3, 2, 4. Solution: determinant N is equal to minus 8 minus 3, 2, 4, which is equal to square bracket open minus 8 in brackets into 4 square bracket closed minus square bracket open minus 3 in brackets into 2 square bracket closed, which is equal to minus 32 minus minus 6 in brackets, which is equal to minus 32 plus 6, which is equal to minus 26. 3. Determinant B is equal to 2 square root 3, 9, 2, 3 square root 3. Solution: determinant B is equal to 2 square root 3, 9, 2, 3 square root 3, which is equal to square bracket open 2 square root 3 into 3 square root 3 square bracket closed minus square bracket open 2 into 9 square bracket closed, which is equal to 18 minus 18, which is equal to 0. Determinant method. Cramer's rule. Let's learn. Using determinants, simultaneous equations can be solved easily and in less space. This method is known as determinant method. This method was first given by a Swiss mathematician, Gabriel Cramer, so it is also known as Cramer's method. To use Cramer's method, the equations are written as a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. a1x plus b1y is equal to c1. This is our equation number 1. a2x plus b2y is equal to c2. This is our equation number 2. Here, x and y are variables. a1, b1, c1 and a2, b2, c2 are real numbers. a1, b2 minus a2, b1 is not equal to 0. Now let us solve these equations. Multiplying equation 1 by b2, we get a1 b2 x plus b1 b2 y is equal to c1 b2. This is our equation number 3. Multiplying equation 2 by b1, we get a2 b1 x plus b2 b1 y is equal to c2 b1. This is our equation number 4. Subtracting equation 3 from 4, we get a1 b2x plus b1 b2y is equal to c1 b2 minus a2 b1x plus b2 b1y is equal to c2 b1. After subtracting, we get a1 b2 minus a2 b1 in brackets into x is equal to c1 b2 minus c2 b1. X is equal to c1 b2 minus c2 b1 divided by a1 b2 minus a2 b1. This is our equation number 5. Similarly, y is equal to a1 c2 minus a2 c1 divided by a1 b2 minus a2 b1. This is our equation number 6. To remember and write the expressions c1 b2 minus c2 b1, a1 b2 minus a2 b1, a1 c2 minus a2 c1, we use the determinants. Now, a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. We can write 3 columns. a1 a2, b1 b2, c1 c2. The values x, y in equation 5, 6 are written using determinants as follows. X is equal to c1 b2 minus c2 b1 upon a1 b2 minus a2 b1, which is equal to determinant c1 b1 c2 b2 upon determinant a1 b1 a2 b2. Y is equal to a1 c2 minus a2 c1 upon A1 B2 minus A2 B1, which is equal to determinant A1 C1 A2 C2 upon determinant A1 B1 A2 B2. To remember, let us denote. Determinant D is equal to A1 B1 A2 B2. Determinant dx is equal to C1 B1 C2 B2. Determinant dy is equal to A1 C1 A2 C2. Therefore, x is equal to dx upon d, y is equal to dy upon d. For writing d, dx, dy, remember the order of columns A1 A2, B1 B2, C1 C2. From the equations, A1x plus B1y is equal to C1 and A2x plus B2y is equal to C2, we get the columns A1 A2, B1 B2, C1 C2. In D, the column of constants C1 C2 is omitted. In dx, the column of the coefficients of x A1 A2 is replaced by C1 C2. In dy, the column of the coefficients of y B1 B2 is replaced by C1 C2. Let's remember Kramer's method to solve simultaneous equations. Write the given equations in the form ax plus by is equal to c. Find the values of determinants d, dx and dy. Using x is equal to dx upon d and y is equal to dy upon d, find values of x, y. Gabriel Kramer, 31st July 1704 to 4th January 1752. This Swiss mathematician was born in Geneva. He was very well versed in mathematics since childhood. At the age of 18, he got a doctorate. He was a professor in Geneva. Solved examples. Example 1. Solve the following simultaneous equations using Kramer's rule. 5x plus 3y is equal to minus 11. 2x plus 4y is equal to minus 10. Solution. Given equations, 5x plus 3y is equal to minus 11. 2x plus 4y is equal to minus 10. Determinant D is equal to 5, 3, 2, 4, which is equal to 5 into 4 in brackets minus 2 into 3 in brackets, which is equal to 20 minus 6, which is equal to 14. Determinant dx is equal to minus 11, 3, minus 10, 4, which is equal to minus 11 in brackets into 4 minus 10 in brackets into 3, which is equal to minus 44 minus minus 30 in brackets, which is equal to minus 44 plus 30, which is equal to minus 14. Determinant dy is equal to 5 minus 11, 2 minus 10, which is equal to 5 into minus 10 in brackets minus 2 into minus 11 in brackets, which is equal to minus 50 minus minus 22, which is equal to minus 50 plus 22, which is equal to minus 28. X is equal to dx upon d, which is equal to minus 14 upon 14, which is equal to minus 1. And y is equal to dy upon d, which is equal to minus 28 upon 14, which is equal to minus 2. Therefore, xy is equal to minus 1 minus 2 is the solution. Activity number 1. To solve the simultaneous equations by the determinant method, fill in the blanks. Y plus 2x minus 19 is equal to 0. 2x minus 3y plus 3 is equal to 0. Solution. Write the given equations in the form ax plus by is equal to c. 2x plus y is equal to 19. 2x minus 3y is equal to minus 3. Determinant d is equal to 2, 1, 2 minus 3, which is equal to square brackets open 2 into minus 3 in brackets, square brackets closed, minus square brackets open 2 into 1 in brackets, square brackets closed, which is equal to minus 6 minus 2 in brackets, which is equal to minus 8. Determinant dx is equal to 19, 1, minus 3, minus 3, which is equal to square brackets open 19 into minus 3 in brackets, square brackets closed, minus square brackets open minus 3 in brackets into 1 in brackets, square brackets closed, which is equal to minus 57 minus minus 3, which is equal to minus 54. Determinant dy is equal to 2, 19, 2 minus 3, which is equal to square brackets open 2 in brackets into minus 3 in brackets, square brackets closed, minus square brackets open 19 in brackets into 2 in brackets, square brackets closed, which is equal to minus 6 minus 38, which is equal to minus 44. By Cramer's rule, x is equal to dx upon d. Therefore, x is equal to minus 54 upon minus 8, which is equal to 7. Y is equal to dy upon d. Therefore, y is equal to minus 44 upon minus 8, which is equal to 5.5. Therefore, xy is equal to 5.5 is the solution of the given equation. Activity number 2. Complete the following activity. 3x minus 2y is equal to 3. 2x plus y is equal to 16. Find the values of determinants in the given equations. Determinant D is equal to 3 minus 2, 2, 1 equal to 7. Determinant dx is equal to 3 minus 2, 16, 1 which is equal to 35. Determinant dy is equal to 3, 3, 2, 16 which is equal to 42. Values according to Cramer's rule. X is equal to 35 upon 7 which is equal to 5. Y is equal to 42 upon 7 which is equal to 6. Xy is equal to 5, 6 is the solution. Let's think. What is the nature of solution if D is equal to 0? What can you say about lines if common solution is not possible? Practice set 1.3. Question number 1. Fill in the blanks with the correct number. Solution. Determinant 3, 2, 4, 5 is equal to 3 into 5 minus 2 into 4, which is equal to 15 minus 8, which is equal to 7. Question number 2. Find the values of the following determinants. 1. Determinant minus 1, 7, 2, 4. Solution. Determinant minus 1, 7, 2, 4 is equal to minus 1 in brackets into 4 minus 7 into 2, which is equal to minus 4 minus 14, which is equal to minus 18. 2. Determinant 5, 3, minus 7, 0. Solution. Determinant 5, 3, minus 7, 0 is equal to 5 into 0 minus 3 into minus 7 in brackets, which is equal to 0 minus minus 21 in brackets, which is equal to 0 plus 21, which is equal to 21. Question number 3. Solve the following simultaneous equations using Cramer's rule. 2. 4x plus 3y minus 4 is equal to 0. 6x is equal to 8 minus 5y. Solution. Let's write the equations in the form of ax plus by is equal to c. 4x plus 3y is equal to 4 and 6x plus 5y is equal to 8. Determinant D is equal to 4, 3, 6, 5, which is equal to 4 into 5 minus 3 into 6, which is equal to 20 minus 18, which is equal to 2. Determinant dx is equal to 4, 3, 8, 5, which is equal to 4 into 5 minus 3 into 8, which is equal to 20 minus 24, which is equal to minus 4. Determinant dy is equal to 4, 4, 6, 8, which is equal to 4 into 8 minus 4 into 6, which is equal to 32 minus 24, which is equal to 8. X is equal to dx upon d, which is equal to minus 4 upon 2, which is equal to minus 2, and y is equal to dy upon d, which is equal to 8 upon 2, which is equal to 4. Therefore, xy is equal to minus 2, 4 is the solution. 5. 4m plus 6n is equal to 54. 3m plus 2n is equal to 28. Solution. 4m plus 6n is equal to 54 and 3m plus 2n is equal to 28. Determinant d is equal to 4, 6, 3, 2, which is equal to 4 into 2 minus 6 into 3, which is equal to 8 minus 18, which is equal to minus 10. Determinant dm is equal to 54, 6, 28, 2, which is equal to 54 into 2 minus 6 into 28, which is equal to 108 minus 168, which is equal to minus 60. Determinant dn is equal to 4, 54, 3, 28, which is equal to 4 into 28 minus 54 into 3, which is equal to 112 minus 162, which is equal to minus 50. M is equal to dm upon d, which is equal to minus 60 upon minus 10, which is equal to 6, and n is equal to dn upon d, which is equal to minus 50 upon minus 10, which is equal to 5. Therefore, mn is equal to 6, 5 is the solution. Equation